Okay, so our guest today is Professor Zhou Wei. He has a PhD in Vehicle Operations Engineering from Central South University, where he currently works. He is currently engaged in teaching and research at the School of Traffic and Transportation Engineering. His research direction includes safety monitoring and evaluation of high-speed trains and freight trains, high-speed train aerodynamics and ventilation systems, vision-based detection, as well as structural fatigue analysis and optimization. His talk today will cover the rubrics of scientific writing. So the topic is how to write a scientific paper. Thank you very much, sir. You have the
Okay,
floor.
thank you. Yes, good afternoon, everyone. It is a great honor for me to give you a lecture to share some of my experience on how to write a scientific paper. So, yeah, I will have a very brief introduction. My name is Zhou Wei. I'm an associate professor in School of Traffic and Transportation Engineering of Central South University. My research interest mainly involves the structural health monitoring of rail transit equipment. I completed my undergraduate, postgraduate for master and doctoral degree in Central South University, respectively in 2005, 2007, and 2012. Then I proceeded as a postdoctor under the guidance by Professor Liang Xifeng in Central South University and Ding Sansan in CRRC. Professor Ding is the chief engineer for 600 km/h MATLAB train and the next generation carbon fiber metro train. And I have been a teacher in Central South University from the beginning of 2013. And so far, I have directed the 23 postgraduates, including 19 master and 4 doctoral postgraduates. My presentation on scientific paper writing will be given in 4 parts. The first part is about the paper structure. A journal paper has 6 sections: the title, the abstract, the introduction, a theoretical foundation, experimental analysis, and a conclusion. Of all the 6 parts, introduction accounts for 60% of the total time, since it is really important to investigate the latest research progress in concerned area. And you need to state clearly the importance and the necessity of what underwent in your own work. And then we need to spend another 15 and 20% respectively on theoretical fundamentals and experimental tests. For the 6 elements of the paper journals, the title acts as the role which can attract readers' attentions. As said in our national standard, the title uses the most appropriate and concise words to express the most important specific contents in a report or a paper. It can be representative of conclusion and the main finding of your paper, and it is supposed to be striking and at the same time vivid. We hereby use the 4 main characteristics to label title. We call brevity, clarity, indexability, and specificity. The title. First of all, the title is not a sentence. It is more concise than a sentence. You can not directly use a complete sentence by saying a robust controller is designed for aircrafts. You can use a phrase structure instead by attributes. Also, do not use acronyms, characters, code names, chemical formulas, patents, and trademark names, jargon, rare or outdated terms in your title, since readers will have difficulty in understanding the exact meaning without the opportunity in understanding ahead by its explanation, because you don't have any space to place the explanation for abbreviations. Do not use subtitles and citations, because published papers should present independent and complete research results, rather than promoting a series of articles with a preface. And try not to use empty words such as study on, evaluation on, observations on, and other self-deprecating words. Do not use vaguer and unspecific title because it will fail to reflect specific contents. At the same time, do not take larger scale or a smaller case scale for real. And do not take a part for the whole and take a whole for the part. For example, here, the title, a numerical method for solving optimization problems, does not give the innovative and specific work the content of your work. Thus, you can specifically specify it is a rapidly convergent descent method, and the method is used to minimize. So you can reorganize your title as a rapidly convergent descent method for minimization. Here we summarize our rules and methods on paper titles for 4 rules. Rule number 1, make each word in your title count. Fewer words will make your title more concise and even better. The second rule, your title should contain and depict your main idea, your innovative work, show the brightest results. The third rule, you can draft a title at the beginning of your manuscript editing. But finally, there do exist a universal formula on title if you don't have other options. You can use based on structure. Here I listed 2 examples. The first initial title, Research on Stress Field Reconstruction and Fatigue Damage Assessment of Railway Vehicle. This one is obviously not clear in stating the specific investigating targets. So the title is also very tedious. We can't get what kind of work has been done in the paper. So after 2 of the revision, we decide the final title as Experimental Fatigue Evaluation of Bogie Frame or metal train. The title contains information of what kind of evaluation, including the method, has been done on what kind of structure. The second title is about a new visual detection method on wind derivation of railway catenary suspension. The original title is tedious and we can't see what attracts readers in the work. Thus, we changed our title as a visual segmentation method based on brightness optimization for railway catenary wind derivation. So here we come to the directory. For the directory, different grade of directory can be represented by its font size, or in letter case, Roman, character, and numerals. No matter what kind of directory you use, you must follow the specific reference to the requirements of the submitted journal. Here I presented the paperwork which are published in Fatigue and Fracture of Engineering Materials and Structures about experimental fatigue evaluation of high-speed trains equipment cabin. As you can see, the red highlighted title denotes the key information the author wants to attract readers and reviewers. It is about the aerodynamic fatigue of trains equipment compartments. The kind of paper regularly includes 3 parts: a theoretical foundation, which supports your proposed work theory; numerical simulation, which makes your theoretical work concrete, and at the same time, in a certain extent, validate your theoretical model. The final experimental work is another convincing way to strengthen your proposed methods. It is indeed necessary and important part for most of the journals. You can make, but you need to make a lot of data discussion over it. This page demonstrates 2 paperwork in different journals. The left work is another wayside measurement method of wheel-rail contact forces and positions. This director illustrates the theoretical model of the measurement method by finite element simulation. And the other part is validation by numerical simulation and experiments. This work is published in JCRQ1 Journal Measurement. You can refer to its directory, then working on similar paperwork. The right side depicts a visual detection work on geometric recognition of honeycomb structure by dynamic window when manufacturing honeycomb products. You can see for this journal, the directory requirements is totally different, but we can understand clearly following its main line for color codes detection to cell nodes remodeling, and finally to the irregularity assessment according to the confirmed cell nodes relationship. And this work is also published in a JCRQ1 journal years ago. For IEE journals, they require a different form for its directories by using Roman numerals and capital letters. For the two work presented in this journal, they give a load identification and a deflection calculation method for load carrying beam, respectively by analytical mechanics and finite element simulation. Those work basically consists of theoretical modeling, method validation, and experimental evaluation, the three parts. Specifically, I want to present the directory before and after final submission in FFEMS about experimental fatigue evaluation of bogie, frame, or metro train. The title which we discussed before, mentioned before about how to make appropriate titles. The directory hereby listed presents a long and tedious subsection titles at the left side. And we need to use clear and short phrases to make them better understood. The primary sections should not be more than needed to tell a good story for readers to get your point. You can see after revisions for several times, the directory gives a very perfect structure of your paperwork. Reviewers can get your point at the first glance. If readers feel to understand your work, you will have a higher opportunity to get your paper accepted or even published. Next, we are going to say something about graphical abstract. What is graphical abstract? The graphical abstract will give a very delightful impression to readers if designed properly. As it can be seen in this page, it is optional for most journals and it concisely summarizes papers' contents in pictorial form to attract attention to a wide readership online. In the graphical abstract, authors should provide images that can clearly represent your work and at the same time, eye-catching and simple to interpret. In many abstracts, authors just use multiple schematics together, sometimes maybe even unclear images to create graphical abstracts. Most of the chart is simple, maybe no introduction or an explanation for its specific contents. Some of the graphical abstract is more like a journal cover with too much art and too little science in it. So there are some basic requirements or rules you can follow when editing graphical abstract. The first is self-explanatory. If so, the graphical abstract can inspire readers' interest by reading clear and direct imaging presentation at a glance. Secondly, graphical abstract should contain less content but be more precise. It should emphasize one particular aspect of your paperwork. It is not the overall summary. You need to show the most important points, the strongest attraction. Third, you should present keywords by using the same common font to support the content and the conclusion of your work. Fourth, you need to make your graphs according to the journal's requirements, including submission guidelines, file formats, layout shape requirements, etc. Finally, do not hesitate to use good and excellent examples from published paper journals, especially of high impact journal papers. This would help you spend less time in completing your graphical abstract. Here, underneath, I presented a graphical abstract describing chemical combination strategy compared with traditional method, which can realize 82% degradation efficiency than traditional 60%. The graphical abstract is very easy to catch by its lively expression and its chemical components and the combination names. Even the sunshine activation mechanisms here is worth to study. Here I will demonstrate some of the cases from my own journal papers indicating how graphical abstract is created. The first case is about the geometric recognition methodology of honeycomb structure based on dynamic window by adopting visual detection. The graphical abstract illustrates the main procedures that the detection undergoes. After the binarized image from the video captured honeycomb images, the dynamic window recognition is performed in 3 stages. The traversing window to reconstruct the contoured data for corner nodes, annihilation window to read image coordinates for each corner nodes, and a tracking window to correlate cells and corner nodes. And finally, geometrical evaluation is conducted based on the identified honeycomb cell node relationship. So this graphical abstract will help readers or reviewers efficiently understand your work. The second case is about the wayside measurement method to evaluate wheel-rail contact forces as well as its positions. The graphical abstract firstly depicts the magnitude and the position definition of the 2 forces by using simple explanations and their dimensions. Then theoretical relationship is given respectively for pure lateral and vertical loading for different node magnitudes and positions. Grouping the relationships from finite element simulation, the load and the position identification method is finally given in terms of the formula, and a specific strain gauge illustration strategy is given in a diagram and real photos. And the third case is about the deflection calculation and dynamic detection of the non-uniform load carrying beam for freight trains. The graphical abstract is relatively simple by organizing different sections in the paper, which includes the theoretical modeling, simulation, and experimental validation, and the final in-transit application. Simple explanations can cooperate with their image illustrations. It's similar for the fourth example when coming to the open beam on wire-haul freight trains. The graphical abstract just describes the storyline for different sections and the subsections in this journal article. Next, I will present the second part, the graphing. Here I listed 5 different graphing tools: the PowerPoint, Excel, MATLAB, Photoshop, and the Microsoft Paint. However, the 5 tools are not overall graphing tools, especially for professional players. For each tool, they have advantage and disadvantage here. I abbreviate them as AD and DIS. The PowerPoint is very easy to learn and be good at. It has the ability to create different shapes with different colors in, develop structural diagrams and data plots, but it is very poor in 3-dimensional graphing and rendering. Excel is the basic tool for Office software. It is powerful in 2-dimensional image plots and employing almost all functions to do your graphing. Anyway, it is unable to perform automatic graphing. MATLAB is a very powerful mathematical software in numerical calculation, symbol calculation, and visualization in different terms. However, the given figure line is not smooth. The font and the other format is difficult to adjust. Photoshop, what we call PS, is very good at background removing and rendering, sometimes reconstructing contaminated images, making your rough original image look elegant and prominent by adjusting its brightness and contrast. Anyway, we still have a lot of other functions to develop in Photoshop. Microsoft Paint is very easy and commonly used, as it were. Anyone can use it and use it well. We can do simple cutting, pasting, splitting job in it. Of course, we can also erase unnecessary information in our original graph. For each tool above, we can't perform a complete job by using just one of them. We can use multiple tools in cooperation to do a good job. Next, I will give you several examples in how to do graphing by using different tools. The first example comes from the dynamic target template matching for catenary suspension motion detection in range area. The depicted is a machine vision method in an attempt to measure the movement of suspension target. In the article, we have to give a very simple schematic diagram telling how the detection works. So I created a projection center and an imaging plane for the camera, respectively as a vertical double-headed arrow and a rectangle plane in PowerPoint in Shapes Inserting menu. So then I draw 3 red circles as dynamic suspension targets. One has initial position, 2 as horizontal and vertical position after moving. So I also labeled dimensions of camera focal distance, object distance, actual and a pixel target offset to make a clear view of how it works. All those shapes, labels, and descriptions are done in PowerPoint in Shape. The second graph shows how the catenary positioning target is identified. In this diagram, we must point out which one is the target template, what is the dimension of the template and the traversing area, and how is the traversing performed along 2 directions, and what is the principle to tell whether the target is successfully recognized. So all those details can be achieved in PowerPoint if you can use shapes and arrows together with labels and descriptions properly in PowerPoint. The PowerPoint can do a lot of incredible things. For example, in this work, we have to validate that our visual detection algorithms works well. Even the camera is installed in vibrating catenary supporting pole due to strong winds. In practical cases, it is impossible to perform validation tests. So we put a vibration platform underneath on which the camera is installed. The vibration frequency and magnitude is set according to what measured in vibration on a supporting pole. Then the hardest part is how can we design a circumstance in which the regular targets move strictly according to what we expected. We use PowerPoint and we define a blue circle target and we design a rectangle moving path, as you can see here. Then the camera observes the target and the algorithm runs to decouple the base vibration. Revised movement detection must be exactly the same as the defined rectangle movement. Only by that, we can prove our algorithm works well. And as you can see, we use this way. It is validated that in this graph that the detected offset in 2 directions agrees well with the theoretical offset in time history as defined in the PowerPoint. Also, the contoured plot of the matching degree, which is defined as the average gray value difference compared between target template and the traversing area, is created in MATLAB programming by using surf function. To better illustrate the corresponding relation with the minimum peak of matching degree to the real target position, we need to use the Photoshop to transform the corresponding image to exact the shape of the dimension of the three-dimensional contour plot plane in OXY axis. So the two views from top and the bottom respectively show the details of detecting index to target. So the contoured curved face underneath, where a distinct peak is observed as the target location. So this graph depicts the cooperation of MATLAB programming and Photoshop processing. Finally, we use our detection method to collect a vertical and a transverse displacement of suspension target. And at the same time, we measured the wind speed time history to better show their following rule. We use double y-axis to display two different kinds of parameters. One is displacement, the unit of which is millimeters. So the other is wind speed, the unit of which is meters per second. So two sets of data share the same time history. In MATLAB or Excel, we can use legend to describe the explanation for each line. Here, we have something to declare. If the time history curve of transverse displacement is below vertical displacement here, readers or reviewers cannot see it. From this perspective, we need to plot the data curve who has the largest magnitude at first, the second largest data curve in the second order. The final plot of data curve must be the curve with the smallest magnitude. Only in this way, details of all data curves will not be covered by each other, okay? The second example here is the load identification and fatigue evaluation by wind-induced attitude decoupling of railway catenary system. At the end of article introduction, we usually have a diagram to show the technical route or paper framework to help clearly show our research logic and the correlation among different sections. For this work, we designed a flow chart in PowerPoint to review supporting relationships among different sections. At each section, detailed key points were listed with arrows and their function to support a specific purpose in order to form a reasonable framework of your article. For this one, we segment the article in three main parts: theoretical formulation, field experiments, and their support for fatigue evaluation. In theoretical formulation, we divide further into three subsections using very short phrases as model description, load identification, and stress calculation. They must be very short and clear enough to indicate their roles in this part. And the same rule follows in other subsections in other parts. In this work, we assume that the wind load on railway catenary mainly comes from horizontal vertical wind. So we only consider crosswind in lateral and vertical direction in Xinjiang wind area. To prove that, we need evidence from what we measured in wind speed and wind direction on railway line at different heights. So the wind vane at the two sides in the picture indicates crosswind direction, and the detected angle is counted in terms of histogram to show the prevailing angle is cross angle according to the wind angle defined above. So all necessary information in the graphs are strong and clear evidence to support our assumption. So these graphs are created partly in PowerPoint and partly generated from MATLAB programming by using its hist function. First to mention, the labeled description here, as you can see. For anemometer, its speed and direction are placed in a three-dimensional form to make it look as the descriptions were placed along the railway line. And this can be realized in PowerPoint. Okay, if you can rotate in a three-dimensional way about different characters. Then we need to declare the load decoupling principle by again using a very clear diagram to show how wind load is decoupled and how catenary locator deviates under each decoupled wind load. Therefore, we need to draw a very simple catenary model with two half span and support components. If you watch at this page, you will find that all the catenary model is just created in PowerPoint, just by using different groups of shapes and lines. During modeling those simplified catenary systems, you need to pay attention to the direction of the lines to make it look as in a three-dimensional view. By using more labeling and description, this graph is more convincing than pure formula description or demonstration. So because it gives reviewers an easy way to understand your idea and thoughts. By running finite element simulation respectively under lateral and vertical wind loading, we read lateral and vertical displacement at the registration points in post-process. We need to plot the results with respect to different displacement versus different magnitudes of the wind pressure. So we usually plot those data in MATLAB programming or Excel. Here, I suggest you do the job in Excel since it requires no complex functions to do it. And it is easier to adjust the format of font size, style, and macro styles in Excel. But in this plot, if you notice, you will see the change between vertical offset in lateral loading and lateral offset in vertical loading. The difference is slight. So we can give a very small sub-window to enlarge the y-axis range to show their local difference. To do so, we need to create another plot and adjust its font size and figure size to fit in the main figure. As an explanation for details of the latest lateral offset in vertical loading. This process requires tools including Excel, Microsoft Paint, and PowerPoint. Another figure gives a similar way to show the details at the two solution roots when we are trying to find the reasonable one with the two. The graph is not only clear in its root location, but also funny, as it turns out a very big smile in the figure. When we come to the catenary support structure components and its connection joints, we use simplified diagram from PowerPoint shapes and real photos together to describe a connection joints names and their locations. Then we use 4 categories of finite element mesh models to group all connection joints. Arrows and labels were used to demonstrate its nodal forces, respectively, as axial and shear force. And this graph is done all in PowerPoint. We can also use the PowerPoint to specify the boundary constraint and the loading condition for 4 kinds of connection joints by using packing shapes with transparent colors to strictly cover the shape and area while constraints and the loading were applied. We can show reviewers clearly well and how those conditions are set before finite element simulation. And this is done again in PowerPoint. In evaluation, we started the correlation between fatigue damage and the different load spectra groups. We found that the absolute damage for all connection components differentiate quite a lot with each other. So we change the y-axis into log in place of 10 to make their difference smaller, so that all the 4 damage curves can be in the same graph. The slight difference is also processed by using a local sub-window to show how it changes in smaller range. The figure underneath depicts the historic wind data in Xinjiang railway line in the past 6 years. So we use the bar plots with different colors in Excel to denote different grade of wind in different years. So the
Hello, so are you there? I can't hear you, I think.
Sorry.
Okay.
How about now? How about
Yeah,
now?
yeah, I can hear you now.
Sorry. Okay. The third example is about the aerodynamic fatigue behavior research of high-speed trains equipment compartment. This article aims to investigating the experimental aerodynamic fatigue problem by relating aerodynamic pressure loads to structural stress, and then use the transformed stress time history to develop load spectra and evaluate its fatigue damage. So the graph in this page gives the experimental scheme of the aero pressure inside the equipment compartment. First, we need to tell which car of the A car train is selected as the testing car by finding image materials on Weber site for head and middle train. Then we use rectangle shape in PowerPoint to represent other middle cars. By highlighting the testing car with a red frame in PowerPoint again, we use a real photo of the local equipment cabin at the head car, and more details are given in the pressure sensing hole on the skirt plate and its way in connecting the pressure sensor with the sensing holes. I was to mention the pressure transmission tube is set with transparent color so we can see the bronze tube inside it. Basically, this page, this figure, this graph is all done in PowerPoint. If we can flexibly use all functions and all shapes, we can make this or even better graphs. Before finite element simulation, components and its dimension, details in mesh grids and constraint boundary condition must be introduced. So if all by words and sentences, its readability will be weak and diluted. So we again use the PowerPoint to describe required information in details by labeling frame. The mesh model is acquired from finite element analysis software in a three-dimensional view. Components model are also plotted in the same orientation to give more details. So descriptions and dimensions are placed partly in front window and partly in three-dimensional view to make it look as if it is lying or standing on the plane of the bottom plates. After simulation, their equivalent stress at different components must be given in graphs by using the same main window and sub window to denote the overall stress distribution and the maximum stress as well as its locations for components. So this PowerPoint made graph is clearly enough to include all necessary information for readers or reviewers. Hereby, rainflow counting and damage accumulation rule on aerodynamic load spectra, 8 grade damage contribution and total damage in equivalent and the first main stress for cabin frame and welding joints are given in terms of bar plots, 2-dimensional and 3-dimensional bar plots with value labels above, via the tool Excel or MATLAB. But here, Excel is more recommended because it is easier to adjust the labels and the title format. As you can see in this page, the divisions of the load and the damage spectra is more than 8 grades. We use 64 grades to plot its cycle counts with respect to the mean and amplitude loads. To make the 3-dimensional bar plot more alive, we developed a new programming code in MATLAB to plot 3-dimensional contoured bar plot as shown in this page. However, as you see the labels, we can't put them in this way in MATLAB. So we erase all the labels from the original MATLAB figure in Microsoft Paint and add the three-dimensional view labels in PowerPoint to make the descriptions for each axis lying on their axis-related plane. So this work requires cooperation graph tools of MATLAB programming, paint editing, and the PowerPoint. Finally, here we cover time history of measured aerodynamic load on equipment compartments. On basis of their Excel-generated data curve, we use arrows, frames in PowerPoint, and descriptions to further denote the details in running circumstances and running directions. So this graph definitely contains all necessary information for readers. The fourth example is a new wayside measurement method we developed for wheel rail contact forces and positions. In theoretical foundation, we need to introduce the calculation details for rail track, including their force and their locations, elements adopted for measuring, constraint boundary conditions, dimensions including slipper spacing, and the specific way to simulate the slippers. So this all can be easily realized in PowerPoint if you are quite good at using transparent frames, three-dimensional view labels, okay? Here to show the strain distribution when the rail track is subjected to deviated vertical loading and lateral loading at the wheel flange, we picked the whole model with contour strain plots and a subplot in front view of its sectional vertical strain so that we can see clearly on the strain difference at the two Weber sides. Those skills can help readers better understand the effect of deviated load-induced bending on structural strain and the stress of real Weber size. To achieve this, we need to get good pictures in finite element analysis software and well organize them in PowerPoint. Here in vertical loading, we use circles, lines, double-headed arrows, and labels to describe different loading positions, magnitudes according to the master nodes in finite element analysis software. All in PowerPoint. Okay, everyone, all in PowerPoint. In lateral loading, we do the same thing. But at the same time, we specify different areas at the real Weber size for studying the strain responses. After simulation and formulation of the force and position identification model, we performed a simulation validation by adopting 10 random loading cases to calculate difference between given and identified loads and locations. So we create these three-dimensional bar plots in different colors denoting different types of parameters. Then we put this figure image in Paint, Microsoft Paint, to erase the original labels. Finally, we put the cleaned image in PowerPoint to place three-dimensional view labels for descriptions for each axis. Okay, this is what we did. Three different tools. For application, we need a diagram to show how strain gauges are bonded on real Weber size. So this can be done in PowerPoint as introduced before, but still, we need real photos to strengthen our points. At the two Weber size, we have an overall photo and a detailed photo to show how strain gauges are bonded. And they have a corresponding relationship with the given diagram at the left. So here, you need to notice the scales for different frames and their colors we set to denote and describe necessary information here, okay? Finally, we need to tell reviewers how we conducted experimental validation tests. First of all, we need to take a very good picture. very nice picture. Well, everything is well placed, but unlike this one, okay. Then we can use lines, the colors of which must be totally different with the background to describe the component's name. And we need sub-window to show details in how to realize deviated loading. All those can be realized just in the PowerPoint. The fifth example is the loading identification and deflection calculation of whole fry train by multiple strain perception at the bottom of load carrying beams. So this work is another typical example of experimental investigation combined with theoretical formulation. So here we give another illustration of paper framework. Well, three parts are involved: theoretical modeling, validation, which includes numerical simulation, loading test, and the final in-transit detection application. This is the example of technical route. We add other key points or challenges for each part. In each frame, we summarizes the keywords and utilizes the typical pictures, which will strengthen our key points. Here at this page to show and highlight our research targets, the loading carrying beam, we use a white rectangle frame, which has a certain degree of transparency in attempt to cover the cargo and other details, but at the same time, highlights the frame with yellow and self-drawn shape on the load carrying beam. By doing this, we will have a clear view of the target and aware of its dimensions and mechanical parameters. The highlighted target still has a connection with the half-covered cargo and other components. So in this way, we will have an overall and a local impression of what the author wants to attract. So the same thing is done for non-uniform load carrying beam with opening holes. We labeled those dimensions and the mechanical properties. In our context, when we tell story between different mechanical properties, reviewers will feel easier to understand and get author's points. So in theoretical modeling, we need finite element simulation to create our model. The given model must contain the location of the forces, how the forces are applied, and how is the load carrying frame is constrained. So we need to acquire very clear picture through finite element software at a proper view to illustrate all the details. Especially for the DK36 Warhol car, we spent a lot of time in getting a very clear picture of the master framework frame model. Because the structure is long and big, if we want to contain the whole master model in abacus or ANSYS, the mesh details will be blurred and indistinct. So we enlarge the window. We enlarge the window to show the details of small parts and the components, and make them plenty of pictures in Microsoft Paint and piece them together as a whole. So this is a very uneasy job, but we have to do it if we want to acquire high quality pictures, okay, everyone? This is very difficult. By comparing the deflection calculation results between theoretical model and the finite element simulation, we use two sets of data and at the same time, the contoured deflection map of single beam and a loading frame to make the data correspond with the practical displacement. This is not hard compared with the cases mentioned before. You only need to adjust the size of visualized model results to proper size and to the proper position. This group of graphs demonstrate the labeling skills in real photos. Those pictures are the on-site loading pictures in order to show dimensions and measuring positions we use to validate our models. To obtain a clear labeling, we first need to reduce those pictures' brightness and the contrast by using the revision function of the image format in PowerPoint. Only in those low contrast images, we can highlight those dimensions and other necessary informations, okay? Including the strain gauge bonding details and the displacement measurement details. Remember. In this work, we finally use our theoretical model to reconstruct the deflection curve face based on the detected dynamic strain. So this three-dimensional deflection can be given in MATLAB programming by using surf function with contour options. So, and we intentionally stretch the range size along the time axis to make the contour plot look reasonable. Then we get the ultimate graph in PowerPoint with notes of the load carrying beam beside it. Okay. The same job is done on Warhol car frame with opening holes. All those deflection face looks like sandwiches, but they look really beautiful. Finally, in vehicle tests, we have to show the rigid displacement measured at different layers of frames. So we take 3 sets of photos at each frame joints, and underneath we put the detected rigid displacement in time history to describe its changes when the train runs on line curves. When creating those data curves, we need to pay attention again. Now, small magnitude curve must be put on top. Larger magnitude curve must be placed at bottom in order that they will not cover each other's key information, okay? The 6th example is a Chinese article about aberration behavior of catenary components when subject to wind-induced vibrations. So this graph shows how we apply nodal axial and shear forces at the connections, and how the bolt pretension forces are applied at the top and the bottom face of the bolting holes. Interestingly, we can also use ring shapes with transparent blue color to depict which area we use full constraint and which use part constraint. This is not very easy to realize in PowerPoint. We also use 2 sets of pictures to respectively denote the contact stress distribution on the bushing gear's inner face and its aberration compared to undamaged profile by using its gray-colored mesh model and its contour map of deflection. So, although the displacement is exaggerated, but it does tell a very clear view of how the inner face is damaged due to vibration. As you can guess, this graph is totally created in PowerPoint. The image materials are from the finite element analysis results. Finally, at the end of the graphs, I want to summarize some skills you need to pay attention to. First, scientific graphing is not limited to PowerPoint, Excel, etc. A region is another powerful software for scientific data processing. Each tool has their advantages. The PS is good at background removing. MATLAB programming plays well in 3-dimensional contour plots and visualization expression via complex functions. Excel is powerful in 2-dimensional plots. The PowerPoint acts well in beautifying graphing and smoothing lines and descriptions font. Microsoft Paint performs detailed fine adjustment and stitching. Cooperate those tools when you are doing graphs, okay? Most importantly, you need to realize that ideas are always more powerful than tools. Graphing ability and skills can be progressing by frequent observing and starting excellent examples published in high-level journals, okay? And only by experiencing and improving your aesthetic appreciation, you can achieve great progress in graphing and mastering all kinds of graphing tools. Next, let's come to tables. We usually use Microsoft Word and Excel to create tables. Tables created in Word is easier to adjust its format to our expectation. But tables in Excel, we can do a lot of things like complicated calculation, automatic generation based on a given formula or rule user-defined. Here is an example of the three-line table before and after revision. The table after the left side sometimes confuses readers by which of the rows belong to different load cases, especially if there are some more than two rows belonging to one case. It is hard for readers to tell. So why don't we just set an extra space between different sets of loading cases and shorten the line space between rows within the case? By doing so, we can easily tell which element belongs to which case, okay? The second example gives another problem when it is difficult to place the nodal forces and pre-stress descriptions in terms of horizontal layout. So we can just rotate the descriptions 90 degrees anti-clockwise, okay? This would save a lot of space and at the same time make your table look harmonious. If you observe the two tables mentioned above, you can see for each element in the table, we have noted its unit clearly at the head title or in the parameter describer in the table. So this is very important. Do not make reviewers guess what the hell is this? What are the units? Okay, always remember. The third table gives another example of how to use row spacing to distinguish different groups of components. The unit here in this table is neglected because of the damage or year, they don't have a unit. And for any acronyms or abbreviations, we need to explain it at the end of the table as note, okay? And this table is more complex because it contains different types of parameters. For each parameter, we have a very simple description on its range and a calculation rule. Attention, this must be very short. Though all those descriptions must be very short to make the table look good, okay? Note is also added and required at the end of this table to explain how those functions work, okay? And what is the meaning of the special bracket. This table at this page illustrates three different kinds of parameters, including the input data and output data respectively as the identified and given. In this paper, you need to notice that the decimal places should be given in reasonable numbers, okay? You don't have to give too many decimal places because sometimes the practical number cannot have that precision, okay? This table is another example for multiple parameter illustration. For each column, we need to specify its units respectively. And for different columns, we need to make a clear bounding to which group it belongs to, okay? For tables, I also made some summaries as below. First, you should leave reasonable number of decimal places for parameters in the table. Second, unit is always required for dimensional data, okay? Third, you can adjust row spacing to make grouping rows look more compact. Fourth, any acronyms or abbreviations in the table should be explained before or at the end of the table as note, okay? Finally, sometimes your description can be rotated, okay, 90 degrees because these English expressions to make your table look better, okay? Oh, the final part. Last but not least, I want to recommend a query app for SCI journals. In WeChat, if we search SCI 茶语头, we can concern this app, okay? We can have a quick search for a specific journal, I don't know, its Q zone, as well as its impact factor. And we can input the keywords to search relevant journals if you want to submit one of them, okay? Okay, that's all for my report. Thank you all for listening. Do you have any questions, everyone? Do you have any questions?
Thank you very much, Professor Joe, for such a wonderful
Yes.
presentation. So the floor is open for questions. You can write them or
Yes, you can write
indicate.
in the WeChat. Yeah,
Okay.
yes, you can write in the chatting dialogue. Oh,
So we'll wait for 2 minutes for questions.
okay.
If you, thank you.
卡斯姆，
老师
I will share this report
Okay.
after this seminar. You can share to others, okay?
All right. I'll do that. Are there any questions? You can raise your hand and I'll let you speak if you want to. Okay, I guess the lecture was very self-explanatory. Thank you very much. Okay. I wish we had okay.
Thank you, everyone.
Thank you very much.
Okay.
On behalf of everyone, all
Yes.
the attendees, we appreciate and we are very grateful for such an excellent presentation from Professor Joe. I'm sure that all other attendees like me have gained very much from this presentation. Thank you very much, sir, for your time and your thoughts. Thank you very much. We really appreciate it.
See you, everyone.
All right, thank you.
Okay.
Okay, everyone, this is the end of today's session. Thank you very much for attending. So bye for now.